Hey class, I made a note about this on the assignment. This is problem number 49. There's 3 parts to it, just like in problem 50 in the back of the book, in the back of the chapter I mean. 50 has 3 parts to it also. If you've already done like problem 50, even though I'm explaining problem 49, then submit the work for number 50. If you're following me, and working through these problems on here with problem 49, then submit that. Yeah, my point is that I'll take either one. I understand that I put 50 in the assignment at the top for like, what the assignment's called. 3B problem set, what was it, 34, 42, and 50. And this time I put 49 in here. So I apologize for the confusion. So watch me go through letter A for 49. I want you to be able to do these 2 things of finding the empirical formula, and then I'm going to show you how to find the molecular formula. We're going to do that for A, B, and C. I'm going to show you how to do A. B and C follow along in very much the same pattern. Okay, so the first thing I do to find the empirical formula is I list the percents that I have for each one. So for carbon here, I have a 92.3%. My first step, and for hydrogen, is 7.7%. My first step is to divide by the atomic mass for each one of these, which is 12.0 for carbon and 1.0 for hydrogen. So 92.3 divided by 12 is 7.69. Notice that for hydrogen it's 7.7. Now I divide both of these like this. I get 1 and 1. Okay. Now 1 and 1 means that my empirical formula is literally CH. Okay, now I have 1 carbon here plus 1 hydrogen equals 13. So 104 divided by 13 equals a magic number of 8. This 8 gets multiplied by that and by that. So C8H8. Now I notice that there's a problem before. When I do this up here, I'm not just doing one of the carbons and one of the hydrogens. Some students are like, no matter what the formula is, like if it's C4H10O like this, you're only taking one like that, and that is not correct. What you should be doing, I noticed this for the finding empirical formulas, the worksheet that we had due last week, what you should be doing is taking 4 times 12 to get 48 here, 10 times 1 to get 10, and oxygen is 16 times 1 to get 16. Okay, and then that changes your answer then. That gives us what, 64 or something like that. Doesn't matter. My point is 74, sorry. But my point is that make sure when you're putting this number down below that you are adding all of them up, including when there's a subscript that has to be taken into account for. Okay, go ahead and see if you can do the same thing. Yeah, okay, now it's messing with me. Go ahead and see if you can do the same thing like I did for part B for caffeine and for, I think the caffeine one's the same. This might be 50. Let me just take a quick look in case there's a question. So for 50, nope. This is still question number 49, and that's fine. Doesn't matter. Tell you what, let me do one more of these here so you can see exactly what I'm talking about. Do the 49.5 for carbon. We're going to divide by atomic mass of 12. The hydrogen is 5.15. Oops. Don't do that. Don't do that to me. There we go. 5.15 and divided by 1.0. And the last one is, there's 2 more left. Nitrogen is 28.9 divided by 14.0. And oxygen is 16.5 divided by 16.0, like that. So when I go through all of these, my first division is atomic mass divided by 12. I get 4.125. I get 5.15. 28.9 divided by 14 is 2.064. And the last one, 16.5 divided by 16 is 1.03. So I divide all of these by the lower one, which is 1.031. 0.031. This one looks like it's going to be 4. This one looks like it's going to be 5. This one is 2, and this one is 1. That means I have C4H5N2O, like that. Now 195 is the molecular formula, and then divided by, so this would be 48 plus 5 plus 28, because 14 times 2, plus 16. So I add all of those up. Is 97. So 195 divided by 97 is 2. That means that my equation then is C8H10N4O2. Not equation, my molecular formula. That is how we do one of those problems. There, I hope that was a little bit more clear. You need to finish letter C to get full credit for this problem set. Good luck.